Good morning everybody. This is Ms. Hazel S. Matthias from the Department of Mathematics, KLS Vishwanath Rao Deshpande Institute of Technology, Haliyad. In the previous class, we were discussing about Fourier series of arbitrary period. So let us discuss about the main things what we have in Fourier series of arbitrary period. Let us write down the general expansion of Fourier series of arbitrary period. So Fourier series of arbitrary period, in that we will be having, what is the general form of a Fourier series expansion? Anybody remember? Anybody remember general form of a Fourier series expansion? So here we will be using the general form of a Fourier series expansion for the arbitrary period. That means suppose if we have the intervals of length 2L. Suppose if we have the interval of length 2L. In that case, how to write the Fourier series expansion, because we have been discussing in the previous class regarding Fourier series expansion of arbitrary period. That in the previous class we were discussing about Fourier series expansion with period 2 pi, but now we are discussing about the arbitrary period. That means the length of the interval will be 2L. Length of the interval will be 2L. 2L. So arbitrary period. L is some arbitrary number which we do not know. It depends on the question. So the general form of the Fourier series expansion of arbitrary period is given by a0 by 2 plus summation n equal to 1 to infinity an cos n pi x divided by L plus summation n equal to 1 to infinity bn sin n pi x divided by L. So this is the general form of a Fourier series expansion of arbitrary period. When we have arbitrary period, we will have the term pi by L. In the previous case, it used to be when you have period 2 pi, it is cos nx. In place of cos n pi x by L, it is cos nx. So here, as we have arbitrary period, we will be having the term cos n pi x by L. So this is the general form. Now we have been discussing certain things. Even here we have to find whether check the odd and even nature of the function. Suppose if f of minus x is plus f of x, we can conclude that f is even. If the function is even, we can conclude that one of the Fourier coefficient, that is bn, equal to 0. If f of minus x is equal to minus of f of x, we can conclude that the function is odd. Therefore a0 is also equal to 0, an is also equal to 0. See, this is the main thing you need to remember before you solve any question on Fourier series. Otherwise, you will end up solving all the three Fourier coefficients. And suppose if it is even, bn will definitely be 0. So instead of struggling so much, what first thing you need to do is you need to check whether the function is even or odd. If it is even, directly you can put bn equal to 0 and you can find a0 and an. Suppose if the function is odd, you can directly put a0 and an are 0 and you can find only the value of bn. That is what you all need to do. So after this, what we have to do is, let us discuss about one by one question. Yesterday I have discussed one question. In today's class, let us discuss one more question with a different kind of interval. Okay, so interval will be different. There are some questions which have been repeated in the previous year question paper, so I'd like to discuss those questions. So here there is one question. A function is given to be defined to be pi x in the interval 0 less than or equal to x less than or equal to 1. That means x lies between 0 and 1. Pi of 2 minus x in the interval where x lies between 1 and 2. So this is the function. Discontinuous function is given. Will you all tell me what is the interval? What is the interval? Looking into these things, tell me the interval. What is the interval?
0, 2.
Yes, it is 0, comma 2 because it starts from 0 to 1 and 1 to 2. Starts with 0, ends with a 2. So the interval is 0, comma 2. See, these things you need to remember. The interval will be 0, comma 2. It will be split into two parts. That is 0 to 1 and 1 to 2. So the length, the original length of the interval will be what? The interval will be 0, comma 2, length will be 2 minus 0, that is equal to 2. So this is the period will be 2. We can conclude that period is 2, and generally we will have 2L. This is general period. This is the general period. In this question we have got period to be 2. So what is the value of L? 2L equal to 2. This implies L equal to 1. If anybody has any doubt, please ask. Anybody wants me to repeat, please tell me.
0,2.
You want me to repeat? Chaitranjali? Anybody wants me to repeat?
Yes, ma'am. Repeat, please.
Yeah, sure. 1 minute. See here, what you need to see is you have a function f of x which is split into two parts. One is pi x, where x lies between 0 and 1. You have, it is defined to be pi into 2 minus x, where x lies between 1 and 2. It is the interval 0, comma 2. See the starting limit, it is 0. See the end limit, it is 2. And 1 lies between 0 and 2. So the interval is 0, comma 2. Remember that it is true in all the cases. Whenever you have discontinuous function, check the starting limit and see the ending limit. It is 0, comma 2. So this is the length. This is the interval. This is the actual interval. You can check in the case of minus pi, comma pi as well. It will be given minus pi to 0 and 0 to pi. So the interval will be minus pi to pi. Okay, so this happens in the case of discontinuous functions. One interval will be there, it will be split into two parts. So 0 to 2 is split in two parts. One is 0 to 1 and 1 to 2. So our total interval will be only one, that is 0, comma 2. And what is, how do you find the length of the interval? It is upper limit minus lower limit. Upper limit is 2, lower limit is 0. So 2 minus 0 is 2. So this is the length. Length is what? Period. Length is period. And here, in order to find the value of L, what is 2L? Here we consider all the questions will have period 2L. We will consider all the questions will be having period 2L. In order to find the value of this L, what we need to do? 2L equal to the period of this question we have to put. The period of this interval is what? 2, because upper limit minus lower limit is 2. General period is what? This is the general period. This is the general period. But the period of this interval is 2. So if you equate these two, you will get the value of L, that is equal to 1. Always remember, suppose if you get the length of the interval is 3 by 2. For example, if you got length of the interval, that is period equal to 3 by 2. In order to find the value of L, you need to equate this with 2L. That time what happens? Value of L will be 3 divided by 4. I hope this is clear. This you have to do in almost every cases where if you do not have the general form. So, because yesterday's question we have discussed minus L, comma L. So here is the length is 2L, and if you equate this with the 2L, L equal to 1. That is what we get over there. So this is the general case. Here you need not worry about it. But when you do not have the general case, you should always equate this with the 2L, whatever it may be. You equate with the 2L, write the period. Here if it is 2, that's why you might be confused. Or else if it is 3 by 2. In order to find the value of L, equate that with 2L. So value of L will be 3 by 4. I hope this is clear. Next. So we have got L to be equal to 1. Next what we have to do is we need to check what kind of equation is this. Okay, we have the equation pi x where x lies between 0 and 1, and one more step, x lies between 1 and 2. F of x is defined to be pi into 2 minus x. Okay, now what we should do over here. What is the next step to be done? Anybody would like to say that what is the next thing we need to do? Check for the odd and even nature, that you can do it at the side only. I don't think so, but just looking into these things only we can make out. Does it happen? Is it an even or odd function? Look into that terms only. Pi x is there. In the next step, pi into 2 minus x is there. Do you think it will be an even or odd function? Do you think it will come in that category? Just tell me what we should do now. We have here 0, 2. This is the interval. See, listen to me carefully. I am going very slowly. The interval is 0, 2. How to check the odd and even nature when the interval is 0, 2? Same concept you use where we have discussed for period 0, 2 pi. Okay, now you compare this with this one. 0, 2 pi, and here we have 0, 2. When we have 0, 2 pi, yes, no, yes, tell me.
Putting x equal to 2 pi minus x.
Correct. So when the interval was 0, 2 pi, what we used to do? We used to replace x by 2 pi minus x. This is what we used to do. Here what we have to do is we have to replace x by f of 2l minus x. Very simple. You have to compare. That's what I am saying here. When I say these small points, make a separate note of it. In one page 0, 2 pi, one more page for the arbitrary period, so that you will understand the difference between them. When the interval was 0, 2 pi, we used to replace x by 2 pi minus x. Now here we have the interval 0, 2. Just you can compare these two and check. That's why we have to replace x by 2l minus x. Our function is over here. Let's take phi of x as pi x, and let's take xi of x as pi into 2 minus x. So this is what we have. In order to find, we have got the value of L to be equal to 1. Now I have to replace x by 2L minus x. Well, let me write over here. Replace x by 2L minus x. L equal to 1. Therefore, replace x by 2 minus x. Replace x by 2 minus x. I repeat once again, when the interval was 0, 2 pi, we used to replace x by 2 pi minus x. I hope you remember, those who have listened or attended my previous sessions. Then, now here the interval is of the form 0, 2. That's why it's a question on arbitrary period. That's why we have to replace x by 2l minus x. But L is equal to 1, therefore 2L minus x will get turned into 2 minus x. So let us replace now pi of 2 minus x. Pi of 2 minus x will x into 2 minus x. Pi into 2 minus x is what? It is equal to xi of x. So what we can conclude? Phi of 2 minus x is xi of x. Therefore, the function is even. Therefore, the function is even. If the function is even, the Fourier coefficient Bn equal to 0. Is it okay, everybody? Is it okay?
Yes, ma'am.
Anybody wants to ask anything, please ask. Okay, if no doubt, we will continue. Function is even, Bn equal to 0. Let us find the value of a0. How do we find a0? The formula is 2 by L integral 0 to L f of x dx. So that is equal to L value is 1 integral 0 to 1 f of x. When the integral values are 0 to 1. When x lies between 0 to 1, f of x is what? Pi x. You have to put pi x dx. Here you have to be careful. Remember this. This has to be done carefully. And those who are not able to do it, see, I really cannot help it because you need practice for this. Without that previous class, I have taken 4 classes to practice those things for you all. 4 classes, 4 to 5 classes. I think this is the 6th revision class. Those 4 classes we have been discussing the Fourier series of period 2 pi only. I have given almost all possible ways. If those things are clear, then this is very easier, because here we are replacing x pi by L. In the previous case, it was 0,2 pi. Here we have 0,2 L. That is the only difference. In the previous case, formula was what? 2 by pi 0 to pi f of x dx. But here is what? 2 by L 0 to L f of x dx. The only difference is that. But finding L values, replacing L values, you have to be careful. So let us integrate this. Pi is a constant. Integration of x, we know integration of x power 1 is x power 1 plus 1 divided by 1 plus 1. So that will be x square divided by 2. So what do we get over here? Limit vary from 0 to 1. So here 2 get cancels, that is equal to pi into x square, upper limit 1 square, lower limit 0 square. So we will get the answer as pi. What is pi? A naught value is pi. A naught value is pi. Therefore, what is A naught by 2 value? It is pi by 2. So this is the value of A naught. Next, let us find An. So for arbitrary period, it's 2 by L, 0 to L, f of x cos n pi x divided by L into dx. In the previous case, how we found An? It is 2 by pi, 0 to pi, f of x cos nx dx. So you can compare now. What is the difference between the previous one and this one? Only pi is replaced by L, and additional term. Here instead of nx, we have n pi x by L. So we know what is the value of L. So it is 2 by 1 integral 0 to 1 f of x. F of x is pi x, because x lies between in the interval 0, 1. When x is in the interval 0, 1, see here it is 0, 1. F of x is defined to be pi x. F of x is defined to be pi x. That's why we are taking f of x value as pi x. Then cos n pi x into dx, because L value is 1. Is it okay, everybody?
Yes, ma'am.
Okay, now we can take this pi outside, 2 pi, and you have product of x into cos n pi x. So take x as the first term, cos n pi x as the second term. Then use the Bernoulli's rule in order to find the integral of product of first and second term. So according to Bernoulli's rule, what we do? We keep the first term as it is, we integrate the second term. Integration of cos n pi x is sin n pi x divided by the constant term in n pi x. The constant term in n pi x is n pi. Then negative sign. Differentiate the x, differentiation of first term, that is x, which is 1, into integrate sin nx. Integration of sin is minus cos n pi x divided by n pi. Previously there is n pi, so it will become n pi whole square, which is n square pi square. We stop till here because in the next step we have to differentiate 1, and differentiation of 1 will be 0, and the limits vary from 0 to 1. So let us substitute the limits over here. What do we get? It's 2 pi into, we have upper limit is 1, and if you put x value as 1, sin n pi we know it will be 0. So here we will have the term 0 itself. Similarly, when you put the lower limit, sin value, x value as 0, sin 0 will be 0 itself. So this entire term will be 0. Next here, minus of minus, it will be plus. We have 1 by n square pi square. Let us write it over here. 1 by n square pi square cos n pi x. When you put the upper limit, that is x as 1, it will be cos n pi. And when you put the lower limit x as 0, it will be cos 0. Cos 0. Now let us simplify that. 2 pi by n square pi square into cos n pi can be written as minus 1 power n minus cos 0 is 1. Then this is the value of an. So let us write all together. F of x equal to a naught by 2. What is a naught by 2? It's pi by 2. So pi by 2 plus summation n equal to 1 to infinity an. What is the value of an? 2 pi by n square pi square minus 1 power n minus 1. This is the value of n cos n pi x by L. L value is 1. And third term is 0 because value of Bn is 0. So this is the Fourier series expansion of arbitrary period for a defined function. Anybody has any doubt in this question? This question is repeated once in the previous year question paper. It has come in the year 17 to June 2017 and December 18. So this has been repeated twice. So you can work out this question. Usually these solved questions only appear in the question paper. You can see the recent question papers of 2020 and because one offline exam was conducted 2020 for 18MAT31 in the year 2020. You can go through that question paper. It is available in VTU website and most of the questions will be repeated. So you can refer previous year at least 4 question papers and you can mark the questions which are usually repeated. So those questions you can practice and definitely one or the only small changes will be there, maybe in the interval or maybe in the function. But if you know the concept, it is easy to solve. Fourier series, please don't mug up. It is not possible for you all to do it. You cannot do it. So understand the concept, practice a question. That is the only solution you all having. Do not blame anybody. You are not going to get anything from blaming. If you don't understand, ask me. I am always there. Any doubt, ask me. I'll help you all with that. But do not ever say we are not able to understand. If you are not able to understand, that means you are not putting your efforts to make it understand. That's it. Any doubt, ask me. I will clarify all your doubts. We will never don't keep your doubts pending at all. Work out the question. For that, you should give your 100% to make it happen. There is nothing which is impossible. 18MAT31 is the difficult paper. Even the students were attending the classes. They were finding it difficult to handle this paper. But you people are luckier because you are getting more time for the preparation. Because we never used to get time for the revision. We used to only complete the portion. But now I have completed the portion as well as I am doing the revision of this Fourier series. Because this is a difficult paper. First 3 modules are little difficult. 4th and 5th, you can do it very easily. No problem in that. Especially the 5th module. It's very easy. So when I'm giving my time, you people have to put your effort. Anything which is not clear, ask. So I'm doing for your good. I hope you all understand what I mean to say. That's it. And I do not want to shout anybody in the class. That's why just be regular to the class so that you will be benefited, not me. By teaching you all twice, it has become all the questions are in my head now. What to do, when to do, etc. So more I practice, I will be perfect. So here also some of you all might be working out along with me. It is well and good. And those who have listening the lecture for the first time, it doesn't matter. Still you can do some of the things. When I give the question, at least you can try to make out whether the function is even or odd, or what could be the value of L, or what could be the general form, what is the formula of A naught, An, Bn, all those things you can write down. So because that is where you go wrong. Later on you may do the calculation part, that is finding the derivative, applying Bernoulli's rule, all those things can be done. But first you have to do a proper start. So here we have one more question. This is little different, so you can work out this along with me. Those who are not able to do it, listen it. So function is defined to be 2x minus x square. This is asked in June 18. This question is asked in June 18. F of x is defined to be 2x minus x square in the interval 0, 3. Interval is given to be 0, 3. Now first you need to find the period. What is the period of this interval? It is very easy. Upper limit is 3, lower limit is 0, 3 minus 0 is 3. So this is the period. I hope everybody is Do not have any doubt in finding the period, upper limit minus lower limit of the interval. Then what you need to do, you need to compare that 3 with the general period, that is 2L. If you equate 2L with 3, what is the value of L? It will be 3 divided by 2. Always you have to do this. Find the period, equate with the 2L, you will get the value of L, that is 3 by 2. Done. Now, what is the Fourier series expansion of arbitrary period with L equal to 3 by 2? It is f of x equal to a naught by 2 plus summation n equal to 1 to infinity a n cos n pi x by L. What is the value of L? We found out, that is 3 by 2. Then plus summation n equal to 1 to infinity bn sin n pi x by L. L value is 3 by 2. So this is the general form of the Fourier series expansion with arbitrary period. Now next what we need to do. What is the next step? I think this question is already discussed, isn't it? To check for the odd and even nature. Is it odd or is it even? Anybody can tell me? Just check and tell me whether it is even or odd. What you have to replace x by? You have to replace x by 2L minus x. So 2 into L is what? 3 by 2. 2 into 3 by 2 minus x. 2 to get cancels. You have to replace by 3 minus x. So function is what? Function is 2x minus x square. So replace x by 3 minus x. What happens? 2 into 3 minus x minus 3 minus x whole square. Now check. 3 2s are 6 minus 2x, 3 minus x whole square. 3 square. What is 3 square? X minus 3 is same as x square. 3 square is 9 minus, it will be what? You will have a quadratic term over here. Then what does it tell me? Minus 6x. 3 into 2 into x. So check whether the terms get cancels. We get here minus x square minus 2x plus 6x. Minus 2x plus 6x is 4x. Then minus 9. So we will get over here minus 3. And it is not same as f of x. Correct. So that's why this function is neither even nor odd. This comes in that category, the function which is neither even nor odd. Okay, so I hope you understand how to check it. You have to find 2L minus x. L is 3 by 2. So you have to, when you put L as 3 by 2, 2 to get cancels, 3 minus x you will get. So you have to replace x by 3 minus x. It's always 2L minus x only. Don't get confused. You can write 2L minus x, then you substitute L for 3 by 2 and you can proceed. But you do not get it as equal to f of x. That's why the function is neither even nor odd. That's why you have to find all the 3 Fourier coefficients, a naught, an and bn. All the 3 Fourier coefficients you need to find. So formula, general case, the function is neither even nor odd. When the function is neither even nor odd, how do we do? What is the formula? It's 1 divided by L integral 0 to L. Is it correct? Is it correct? What is the general formula? Anybody remember what is the general formula? Yesterday I had given that general formula. It is 1 by L. Integration of the original interval, that is 0 to 3. 0 to 3. F of x dx. This is the formula. General formula, it was given in terms of c comma c plus 2l. Suppose if you have c comma c plus 2l, interval as c comma c plus 2l, f of x is given to be 1 by l integral c to c plus 2l f of x dx. This is the general expansion. The problem comes when when you have a function which is neither even nor odd in this interval. May not be all the time. In this interval it is neither even nor odd. That's why what you need to do, f of x formula is 1 by l. L is what? 3 by 2. So it is 1 divided by 3 by 2. Here for the integral you have to put the original interval, that is 0 to 3. 0 to 3. F of x is what? 2x minus x square into dx. So 1 by 3 by 2 is 2 divided by 3. Let us integrate it. 2 times x. 2 into integration of x. Integration of x is x square by 2. X square by 2 minus integration of x square is x cube by 3. I hope you all know integration of x power n with respect to x. It's x power n plus 1 divided by n plus 1. So we will have x square by 2 minus x cube divided by 3. Let us put the limit. It varies from 0 to 3. Just check now here what happens when we put the limits. 2 get cancelled. We have, this is what, a naught, sorry, a naught. A naught equal to 2 by 3 into, put the limits for x square, upper limit is 3 square minus lower limit is 0, then minus second term 1 by 3 into 3 cube, upper limit is x 3, so 3 cube minus 0. So what do we get over here? It's 2 by 3 into 3 square is 9. Here what do we get? 9 minus 9. 3 cube by 3 will be 3 square. 3 square is 9. 9 minus 9 which is 0. So we got a naught to be equal to 0. A naught by 2 is also equal to 0. Okay. See, the function is neither even nor odd. It doesn't mean that a naught should not be 0. It may be 0. Some cases it will happen to be 0. So do not have that confusion that function is neither even nor odd. A naught should not be 0. There is no condition like that. But the function is even or odd. If the odd, then means a naught and an both will be 0. Let us check now what do we get the value of an. What is an formula? Same formula, 1 by L. L is 3 by 2. Integral the given interval, that is 0 to 3. F of x is 2x minus x square into cos n pi x by L. L value is 3 by 2 into dx. Cos n pi x by L. So that is equal to, here 1 by 3 by 2 can be written as 2 by 3. Then what do we do over here? Let us take this as first term and this as second term, and see this one, cos n pi x by 3 by 2 can be written as, this 2 you can take it to the numerator, cos 2 n pi x by 3. This is just for the simplification I am telling, so that the terms will be easier for you all to write down, or else you have to write again by 2. So what we do, we shall write cos n pi x by 3 by 2 as this 2 goes to the numerator, so it will become cos 2n pi x by 3. So we'll write the second term as cos 2n pi x by 3. Let us evaluate the integral of this. What do we do when we find the integral of product of two functions? First term will be written as it is, that is 2x minus x square. First term will be written as it is. Then integrate the second term. Integration of cos 2n pi x by 3. Integration of cos is sine. Sine 2n pi x by 3 divided by constant term in 2n pi x by 3. What is the constant term? 2n pi by 3. So you have to divide by that term, 2n pi by 3. I hope this is clear to everybody. Integration of cos 2n pi x by 3 is sine 2n pi x by 3. Then you have to divide then negative sign. Differentiate 2x minus x square. Differentiation of 2x is 2. Then differentiation of x square is minus 2x. Is it okay, everybody?
Ma'am, that A1, A naught is equal to 2 by 3 remains, now, ma'am.
2 by 3 into 0, no, it is 9 minus 9 is 0. 2 by 3 into 0 is 0. This is into, not addition. Am I correct?
Yes, ma'am.
Yeah. Now an first term is here, integrated the second term, then negative, differentiate 2x minus x square. Differentiation of 2x is 2, differentiation of x square is 2x. Then integrate this one. Integration of sine is minus cos. So minus cos 2n pi x by 3 divided by 2n pi by 3. 2n pi by 3 is already there. So it will become 2n pi by 3 whole square. Then the third term, you have to differentiate 2 minus 2x all once again with the addition plus sign, because you have to give alternatively positive, negative, positive sign. So differentiation of 2 minus 2x, differentiation of 2 is 0 and differentiation of minus 2x is minus 2. Minus 2. I hope you all know differentiation and integration. Differentiation and integration, if anybody doesn't know, please contact me. I'll give the standard results so that you can remember them. So differentiation of 2 constant is always 0 and differentiation of 2x, because differentiation of x is equal to 1. So we will have the term minus 2. Then integrate this once again. Integration of cos is sine 2n pi x by 3 whole divided by 2n pi by 3. 2n pi by 3 whole square is already there, so it will become 2n pi by 3 whole cube. I hope this Bernoulli's rule is clear to everybody, because we have been repeated quite many times. We are not writing the third step because differentiation of minus 2 will be 0 and the limits vary from 0 to 3. Now just substitute the limits whenever sign is there. What happens if you put x as 3, 3 get cancelled, sine 2n pi you will have. See, multiples of n pi, it may be 1, 2, 3 or whatever. Sine 3n pi, sine 4n pi, multiples of n pi, sine will always give you the value 0. Okay, remember that always. Sine will always give the value 0. Sine n pi as well as lower limit is 0. That's why this term is 0. Similarly, the third term, multiples of, when you put 3 get cancelled, sine 2n pi, sine n pi, sine 2n pi, multiples of n pi for sine will always be 0. Similarly, lower limit, sine 0 is also 0. So only the second term remains. So we have 2 by 3 into, see here, minus of minus. Here there is a negative sign, here there is a negative sign, so it is plus. What we have? 2 minus 2x. Then what we have here in the denominator? 2n pi by 3 whole square. 2n pi by 3 whole square. How can you write it? The constant term, let me write it over here. It is 1 divided by 2n pi by 3 whole square. That means this 3 square goes to the numerator. It will be 9 divided by 2n pi whole square. 2 square is 4, n square, pi square. This is what we get it over here. That is 1 divided by, it is 1 divided by 2n pi by 3 whole square. So this denominator goes to the numerator. It will be 9 divided by 4 n square pi square. Then what terms remaining? 2 minus 2x cos 2n pi x by 3, cos 2n pi x by 3. For that we need to put the limits. Then what happens when we put the limits? Here we can cancel out terms. 3 1s are, 3 3s are, 2 1s are, 2 2s are. So we get 3 by 2 n square pi square. Now to the terms which are inside, put the limits. When we put the limits, first is 3. So 2 minus 2 into 3. 3 2s are 6, 2 minus 6 is minus 4. Here when you put x as 3 get cancels, cos 2n pi. So what is cos 2n pi? Anybody remember what is cos 2n pi? I'll write, tell me. Second one, lower limit. When x is 0, if you put this as 0, 2 minus 0 will be 2 and cos 0 will be 1. Tell me what is cos 2n pi. When you put x as 3 get cancels, cos 2n pi remains. What is the value of cos 2n pi?
1.
Very good.
1.
Yes, yes, very good. Others are satisfied with that answer? Why is it 1? Why cos 2n pi is 1? What is cos n pi? We always write directly, isn't it? Minus 1 power n. And I say the value whether it is plus 1 or minus 1, it depends on n. If n is odd, it will be negative. When n is even, it will be positive. So what's the difference with 2n pi? Cos n pi is minus 1 power n. What will be cos 2n pi? Minus 1 power 2n. It is what? Multiple of 2. Multiple of 2 is always an even number. Remember that. Multiple of 2. 2, 2 2s are 4, 2 3s are 6. 6, 8, 10. So these are all multiples of 2. And when you have minus 1 power an even number, minus 1 power even number is always equal to 1. That's why cos 2n pi value is 1. Write down this if you have a doubt anywhere. Cos 2n pi value is minus 1 power 2n and minus 1 power an even number is equal to 1. So here what we have? Minus 4 minus 2, it is minus 6. We have minus 6, 2 1s are, 2 3s are. So we get over here 3 3s are 9. Minus 9 by n square pi square. This is what? Value of an. Anybody has any doubt? Anybody has any doubt in an?
Ma'am, that is minus 3 by n square pi square, ma'am.
That here a 3 is there, no? So 3 into 3 minus 9. Correct? Shilpa? Got it?
Yes, ma'am.
Yeah. Let's move on to finding Bn now. What is the formula here? This is neither even nor odd, so you have to find all the three Fourier coefficients. So Bn is given by 1 by L value is 3 by 2, integral 0 to 3, f of x. What is f of x? It is 2x minus x square into sine n pi x by L. L is 3 by 2, so 2 comes over here. Here it will be like this because L value is 3 by 2. So sine 2n pi x by 3. Now in order to find this, apply Bernoulli's rule. First term and the second term, 1 by 3 by 2 will be 2 by 3. First term keep it as it is, 2x minus x square. Integrate sine 2n pi x by 3. Integration of sine is minus cos 2n pi x by 3 whole divided by the constant term which is 2n pi by 3. Then negative sign, differentiate 2x minus x square. Differentiation of 2x is 2 minus differentiation of x square is 2x. Now integrate this. Minus sign is already there. Integration of cos is sine. Sine 2n pi x by 3 whole divided by 2n pi by 3. Once 2n pi by 3 already there, so it will become 2n pi by 3 whole square. The third term with a plus sign, differentiate to 0, differentiate minus 2x, it is minus 2. So we get minus 2, integrate this once again. Integration of sine is minus cos, minus with this minus will become plus cos 2n pi x by 3 whole divided by 2n pi by 3 with this term. It will be 2n pi by 3 whole cube and the limits vary from 0 to 3. Done? Now put the limits. Now put the limits. This is going to be little complicated over here. What happens? Just check. 2 by 3 into. Now you put the limits. What happens? See, upper limit is 3. If you put over here 2x minus x square. 2 into 3 minus 3 square. That is 9. What happens? 3 2s are 6. 6 minus 9 is minus 3. And here you have 2n pi by 3. Correct? Am I correct? Okay, so here we have 2n pi by 3, so it's 3 into 2n pi, because this goes to the numerator, 3 by 2n pi it will be. Then now put the upper limit, that is 3 to this. 3 get cancels, cos 2n pi. You have a negative sign over here. Am I correct? Negative sign with this negative, it will become plus. Cos 2n pi is, we have just said, we have the general formula, cos 2n pi equal to 1. So this is equal to 1. This is the upper limit for the first term. Now put the lower limit for this term only. Lower limit means minus sign. If you put x equal to 0, both the places, it will be 0. So 0 into this entire term, it will be 0. So we have put both upper limit and lower limit for first term. Second term is going to be 0 because we get sine 2n pi. When I put 3 over here, sine 2n pi, which is 0. If I put the limit as 0, sine 0, that is also 0. So this term is going to be 0 plus 0. Then we have this term now, third term. So here we have in the denominator 2n pi by 3 whole cube. It is minus 2 into 2n pi by 3 whole cube. 3 cube, this goes to the numerator. So it will 3 cube is 27 divided by 2 cube is 8, n cube pi cube. This is what we get. Now put the limits for this term. When you put the upper limit 3 get cancels, cos 2n pi, which is equal to 1. When you put the lower limit, what is the lower limit? Lower limit is cos 0. Cos 0 is what? It is equal to 1. So here it also be 1 minus 1, it is 0. 0 into this entire term. So this term also is going to be 0 because cos 2n pi is 1 and cos 0 is 0. When you put the upper limit 3, you get cos 2n pi. Cos 2n pi is 1. When you put the lower limit 0, that is cos 0. Cos 0 value is also 1. So this term is also going to be 0. So only this term remains. So what is Bn? You can cancel out few terms over here. See, this 3 and this 3 get cancels. 2 and 2 get cancelled. So we get only 3 by n pi. Anybody has any doubt? We get Bn equal to 3 by n pi. See, when I show this, you will not understand where you will get stuck. So after this class, I have discussed 2 questions in this class. The same thing, you take it and start working out because they are the questions which are repeated. So you can work out these questions so you will understand where you are going wrong, which step you are having a difficulty, how to do it. Especially Bernoulli's rule is quite confusing sometimes. That's why same questions what I discuss, you practice this after this class. So Bn we got it to be 3 by n pi. Now write all the values in the expansion of f of x. First we have f of x equal to a naught by 2. It is a naught by 2, it is 0. A naught by 2 is 0. Next we have an, that is minus 9 by n square pi square. A naught by 2 is 0 plus summation n equal to 1 to infinity minus 9 by n square pi square cos n pi x by L. So n pi x by 3 by 2. So I can also write it as cos 2n pi x by 3. Plus third term, summation n equal to 1 to infinity Bn. Bn is 3 by n pi. 3 divided by n pi, sin n pi x by 3 by 2, it will be 2n pi x by 3. So this is the Fourier series expansion of the function 2x minus x square in the interval 0, 3. Is it okay, everybody? So I will give one question for you all. It's the same function. F of x is equal to 2x minus x square. Find the Fourier series expansion of this in the interval 0, 2. So this is 0, 3. Now we have 0, 2. First check what is the period. After period you find it, equate it with 2L. Then find the value of L. Then check the odd and even nature. Check odd and even nature. That is replacing x by 2L minus x. Replacing x by 2L minus x because it is of the form 0, 2. Whenever you have 0, 2 pi, what you do? You replace x by 2 pi minus x. Similarly, 2L minus x. Substitute this L, whatever you get it. Then you get something that you replace x by this term. Then check for odd and even nature, and you know if it is even, bn equal to 0. If it is odd, a0 and an are equal to 0. So hence you have to find the Fourier series expansion. This is the homework. You can do it after my class, and if you have any doubt, any extra question you need to work out, just you can send me so that we can work out in tomorrow's class, or else I'll discuss few more questions in tomorrow's class. So I'm going very slowly so that Fourier series concept will be clear with everybody. If any one of you have missed the classes, you can watch the recordings which are available on YouTube. Okay, so I hope that there is no doubt. If there is doubt, work out the questions. Still, if you get any doubt, please contact me. Do not hesitate. At the same time, do not keep the doubts pending. Okay, let's meet in tomorrow. Yes, tell me.
Ma'am, we need a YouTube link, ma'am.
Okay, I'll send it to you. I'll put it in the group, civil third semester group. I'll put that. There you will get all the YouTube, all the videos related to the subject. All the videos are available there. Not only mathematics, all the videos are there. So you can segregate and go for whichever you want. Okay?
Yes, ma'am. Thank you, ma'am.
You're welcome. Let's see you all in the next class. That's tomorrow morning. Thank you, everybody.
Thank you, ma'am.